Welcome to this IB Maths Intense session on the binomial theorem, our second video, this time building on what we did in the introduction to show you some basic expansion problems. And simply all I'm going to do here is just show you 4 examples, different types of expansion that you might have, just to give you a prompt as to what things you should look out for. But really, this is a topic where, as we showed last time, you just need to be familiar with this good old formula that's on the formula sheet and be able to use it. And it's made up of 3 components, A and B and N, which are given in our binomial problem. Let's do some simple examples then. So 1 plus x to the power of 5. Best thing to do if you really want to be thorough is just write down beforehand, what are your 3 values here? A is 1, B is x, and n is 5. And then you can just fill in the formula as per the formula sheet. Now I know that all of my NC1s, NC2s and so on, this is the 5th row of Pascal's triangle, so I can just write down straight away what my values are going to be at the beginning. I know I'm going to have 1, I'm going to have 5, I'll have 10, I'll have 10, I'll have 5, and then I'll have 1. Notice that when n equals 5, there are 6 terms in the expansion. There's always one more term than the power that you're expanding, because we have to cater for the case for when n is equal to 0. Now the next thing to do, I can join those together with plus signs for now, because that's what the formula tells me. And then I'm going to fill in my values for A and B. Now the great thing about having 1 as the first part of the problem is that 1 to the power of anything stays as 1. So I really don't need to worry about 1 in any of those terms. I can ignore it. So let's go through. So the first one doesn't have any power for b, it's b to the power of 0, so b doesn't exist there. In the second term, I have a to the power of 4, 1 to the power of 4, don't need to write it, multiplied by b to the power of 1, so in other words just x. And then following the pattern, you'll see the next one becomes x squared, the next one's x cubed, x to the power of 4, and then x to the power of 5. 1 doesn't come into play here, I can just ignore it. And that gives me a very, very simple binomial expansion. And now, of course, I can get the eraser here and just get rid of the 1 at the end, because I don't want to write 1x to the power of 5. It doesn't look very professional. So that's your simplest case. Now, the second example is exactly the same, but I just wanted to highlight to you that you might have a value for b, which is negative. So a is equal to 1 here, b is equal to negative x. And we need to be a little bit careful with our powers when we're using a negative number, and n is still equal to 5. So like before, I'm just going to write down first of all my coefficients pulled from Pascal's triangle, but you could have done them with your calculator. And I'm going to put my plus signs in there just for now, because that's what the formula says. Like before, I can ignore the 1s now, because 1 to the power of anything is going to stay as 1. So the first term is just going to be 1. Second one is going to be 1 to the power of 4. I can ignore that. And then times b, and my value for b here is, careful, minus x, not just x. The second term, it's going to be negative x squared. The fourth term, is going to be negative x cubed, then negative x to the power of 4, and then finally negative x to the power of 5. Now, hopefully you'll remember from your laws of indices or powers that when you square a negative number, it goes positive. So that will have a bearing on the signs in this solution. So I'm going to end up with 1, and then it's going to be minus 5x, because 5 times minus x is minus 5x. The next term will be positive, because minus x all squared is positive. And then we go negative again, and then positive again, and then negative again. And you'll see that pattern going positive and negative as you go through. So again, not too difficult, because my value of a is 1, so I really don't have to worry about that. It's just a placeholder, really. Now what happens when I get a mixture? So let's go with, this time, 2 plus 3x to the power of 4. So write down what you know. A is equal to 2, b is equal to 3x, and n is equal to 4. So again, I can pull from the fourth row of Pascal's triangle or use my calculator to find all the coefficients. 4c0 is 1, 4c1 is 4, 4c2 is 6, and then 4c3 is 4, and 4c4 is 1. There are the numbers at the beginning. I like to get those out of the way so my brain isn't having to focus on too many things at the same time. Now the first term, I can't just ignore the fact that a is equal to 2 anymore in the way that I could when a is equal to 1. So what I'm going to write in here is the first term, it's a to the power of n, in other words 2 to the power of 4. And then the next term, I'll have 2 to the power of 3 multiplied by my value for b, which is 3x. The next term, 2 to the power of 2 this time, and 3x, also all to the power of 2. The powers for the 3x are going up by 1 each time, as the powers for 2 are going down by 1. The next term, 2 to the power of 1, and then 3x all cubed, and then finally I'd have my 3x all raised to the power of 4. Now, I have to be careful, make sure I do the maths right here. 2 to the power of 4 is 16. And then I've got 3 times 2 to the power of 3, 3 times 8, and then times 4. And that will gives me 96. So I've got 96x. Third term, 3 squared 9 times 2 squared 4. 9 times 4, 36 times 6 is 216. And this time it's x squared. The third term, 3 to the power of 3 is 27 times 2, 54 times 4, 216 again, x cubed. And last but not least, I'm raising 3 to the power of 4, which is 81, and multiplying it by 1. 81 x to the 4. Now again, that's a little bit more difficult this time because I've got to deal with both values for a and b. The one doesn't just disappear as it did before. This time we've got to actually raise 2 to the power of things. So let's finish with a more tricky question. This time my values for a and b both involve x, so I'm going to have to be extra careful when I'm working out my powers here. A is equal to x squared, and just to make things even more difficult, b is negative. It's x over 2. It's a fraction. My value for n is 4. So like before, I'm going to get all the coefficients out of the way. I've got a 1 to start with, a 4, a 6, a 4, and a 1. Let's join them up with positive signs for now, but I might have to change that when I expand out powers with a negative. The first term then, my value for a is x squared, and I'm raising it to the power of n, which is 4. There it is. The next term, my value for a, x squared, will only be to the power of 3, and I'm going to multiply it by my value of b, minus x over 2. Then the next term, x squared, will only be raised to the power of 2 this time, but minus x over 2 will be raised to the power of 2 as well. Then I'm going to have just x squared to the power of 1, and negative x over 2 raised to the power of 3, and then last but not least, negative x over 2 all to the power of 4. Now, no panic, just go through each term and remember your laws of indices, and this should be straightforward. X squared to the power of 4, power of a power, we multiply the two together, so I end up with x to the power of 8. Now here, I've got x squared cubed, which is x to the power of 6, but I'm multiplying it by another x, so I end up with x to the power of 7. I have a negative, and that's not been squared at all, so it stays negative. So I end up with 4 divided by 2. I've just got 2x to the power of 7. The next time round, I've got x to the power of 4 here, multiplied by x squared, gives me x to the power of 6. And this was negative, but because I squared it, it goes plus. Now, don't forget that the fractional term, 2 on the bottom, is being squared as well. So I'm going to have 6 divided by 2 squared, which is 6 over 4, which is 3 over 2. And then I'm going to have a minus here because I'm cubing minus x, so it will give me a minus x cubed. I've got x squared, multiplying it by x cubed. I'm going to have x to the power of 5 here. And just being careful here with the maths, 2 cubed on the bottom, that's 8, multiplied by 4 gives me 4 over 8, which is a half. And then last but not least, I'm raising a negative number to the power of 4, so it will give a positive result, x to the power of 4, and then on the bottom, 2 to the power of 4 is 16. There we go. Now, this is just about practice and being comfortable with using the formula. Watch out for your values of a and b, watch out for negatives, watch out for raising powers of a power. Watch out for these cases where you've got x in both the values of a and b. Just makes it a little bit more complicated, but don't be afraid to write everything down. You won't get marks taken away from that. It's good practice. So there we go. Thank you for watching. You do some more practice questions yourself. In the meantime, don't forget to like this video, subscribe to my YouTube channel, IB Maths Intense. Tell your friends I'm here, and don't forget to drop me an email on ibmathsintense@gmail.com if you've got any requests, if you've got any questions, or if you've spotted any mistakes that I might have made. So enjoy your maths and take care.